Can you recognize this problem? You have a web shop or an online sales platform, and at some point it becomes slow. So what do? You throw a bigger machine at it. So basically, you're just providing a bigger engine. This thing is called the vertical scaling, because of course it has its boundaries. The worst thing is, or the second part of the problem is, you figure out that in a couple of weeks or a month, it's slow again. So what do you do then? Well, you have to start fixing the code, or you're looking for other solutions. And you figure out that all this costs a fortune, and it's not that easy because you're actually basically hitting the ceiling. The thing is, this can be fixed. A lot of performance issues can be usually fixed by providing better code. But there is also another way. When you actually have a good code and you're no longer able to service your customers, this is exactly when horizontal scaling becomes very important. Keep on watching my video, because I would like to explain you horizontal scaling in a slightly different way than normally, and I will do this by going into this building. Let's go. How can I explain you the classical let's throw a bigger machine problem? Let's do it on an example. As you can see, this is how it starts. You start with the machine where you're putting your web shop or online sales platform, and it works. You're getting more and more customers, so obviously at some point you have to move to a bigger machine. If you do everything right, of course, you're becoming more and more successful. And this, what I'm showing you, that you are jumping to bigger and bigger machines, which is a classical example of vertical scaling. This is actually a great use case, because this is exactly how it should work. But then what happens? Usually two problems. First one is that you are outgrown by your own success, which basically means you're getting so many customers you can no longer deal with them. Or you get people to work on your code, and the code they are adding maybe is not of the best quality. I have just mentioned two main issues that we have with vertical scaling and why things fail. Guess which one I have met most in the past 12 years. It's the combination of the two. So basically, usually it's people are outgrown by their own success, and because everything happens so quickly, they also add a lot of bad code that doesn't scale, it's not really thought through, and so on. So what happens then? Then of course they have to fix it very quickly. What they do then, they actually buy an epic machine. So they basically get something of that size. And it's becoming ridiculously expensive, and later on, they find out that still this doesn't work as it should, because bad code will not scale well. Because bad code will not scale well, even on a fast machine. And the problem is, then they buy something like that. You see the big ones? Yes. The biggest problem with the big ones is that they will work very short. The other problem is, imagine what happens when things go bad in one of the small cauldrons. What is the risk associated with that? Imagine everything in this one is spoiled. Even worse, imagine everything you're producing is put in one of those, the big ones. Basically, your business stops and you can't do anything. And this is exactly when horizontal scaling becomes very important. What you have to remember also is that it doesn't make sense to produce perfect code. The code has to be just good enough so that you are getting the most of the vertical scaling. Getting a perfect code is not going to be economically feasible, because you'll be thriving for something that will not pay off in the way you would expect. So just get the code good enough so that it scales. Once you have that, then we can start thinking about actually going into horizontal scaling.
Horizontal scaling means increasing the capacity and performance of an application by adding multiple servers to share the workload. Take a look at this cask. Imagine the waiter's job is to fill as many rum glasses as possible. With just one cask, we can process only one glass at a time. When you get many guests at one time, it might be difficult to keep up with the demand and hold the queue at an acceptable level. Now imagine we have all these casks available with a waiter next to each one. That means we can fill as many glasses as we have casks simultaneously. That's exactly it. Horizontal scaling, having multiple waiters filling glasses at the same time. There is one thing missing here though, namely a load balancer. It's a tool that is responsible for distributing incoming requests between servers in a way that prevents single machines from being overwhelmed. In our example, that would be a greeter at the door directing customers to waiters that have the capacity to fill new glasses. Can any application be horizontally scaled? No. And it's often data itself that limits what we can do in terms of processing. Is it expensive? Well, it depends. It's just like with printing press. Getting the press, setting up a template and so on, that requires a certain investment. But once you have it, then you can just produce a lot of copies at a low cost. Exactly the same situation is here. Initially it will cost you, but then further scaling is very cost effective. When you compare it to vertical scaling, here you can actually add more low-cost machines and you can even mix and match them behind. I said it before, but will it speed up my bad code if I actually add horizontal scaling? No, it won't. It will temporarily alleviate some performance issues, but you'll be hitting exactly the same bottlenecks very soon. The rule is very simple. Have a good enough code before you scale it out. What are the other use cases for horizontal scaling? Well, if you have fluctuating or growing traffic, this is a classical example. But with horizontal scaling, you can also increase your availability. When you have a lot of machines behind a load balancer, if some of them die, the remaining ones will simply take over. Exactly in the same way, you can perform upgrades that your customers won't even notice. So the question is, when to go horizontal? If you ask me, it's when you can see consistent high load on your servers, or when you have seasonal sales and things simply go down, making you lose revenue. You can also plan ahead, especially if you know that increased traffic is on the way, because let's say you have some ad campaigns or you plan actually to become very famous very soon. What is auto-scaling? Because probably a lot of you have heard that term. Well, auto-scaling is a fantastic feature. It means that the number of machines behind a load balancer is automatically controlled. When there is a high load or a high demand, new machines are added. When the traffic is low, the number of machines is reduced. It's a great feature, although it requires a little bit more planning. Basically, there is a lot more theory behind horizontal scaling, and covering everything in one video would make it simply unwatchable.
There are different ways of introducing horizontal scaling into your application. It can be done in a way that you can actually cheat the application behind and make it scalable. It will though require quite a lot of solutions on the DevOps side, but it is possible. Of course, the best results will be achieved when you're able to modify the code a little bit and actually make sure that your application is suited properly for horizontal scaling. If you ask me what I was doing in the past many years in my career, I was also actually doing this, identifying in the applications how to make sure that we can get all these tasks running so that my customers can process even more customers and be more resilient to failures and errors. So, horizontal scaling is a form of distributed computing. And of course, distributed computing means that a little bit more knowledge is required and a little bit more work is required in order to get everything up and running. But as I said before, it's definitely worth the effort, and the amount of money you're going to invest in your horizontal infrastructure, this is going to be very quickly brought back by the additional revenue that you're going to generate. By the way, I nearly forgot about this one. When you're building an application, it's much easier to add rudimentary support for horizontal scaling because you don't have to implement everything. There's just a couple of easy tricks that you have to remember in order to get it to work. So, if you have any questions, of course, you're welcome to write in the comments. If you would like me to take a look on your application and figure out how easily it can be scaled horizontally, just contact me.
Of course, I wouldn't let you go without sharing the tips first. So the first one is keep it stateless. Design your app so it doesn't rely on previous interactions or store user data between requests. It makes it much easier to add more servers later on. If you cannot do that, and to be honest, this is quite often that you cannot, make sure you're able to store, a classical example, session data in an external service like for example Redis. This way you won't have problems later on. Point number 2, optimize your database. Make sure it really runs efficiently. Make sure you have control over indexing, you are using pagination, and so on. It really helps prepare it for horizontal scaling. Because you have to remember one thing, all the workers, all the machines behind the load balancers, they will be talking to your database. And of course, there are techniques for horizontal scaling of databases, but remember one thing, it's getting very quickly very expensive. Point number 3, use caching. Store frequently accessed data in a cache to speed up your app and reduce the load on your database, because as I said, it's getting quickly very expensive here. Point number 4, separate components. Break your app into smaller parts. And when I say that, you can start with making sure you have a web server, you have a database server, you have a queue server, and so on. It really makes it easier to scale each part independently later on. Point number 5, speed up tasks. Move time-consuming tasks to the background so that they don't slow down the main application. In other words, it's also called background or deferred processing. It means that you are keeping your requests as quick as possible and let the long stuff happen behind the scenes. The thing means that you don't want your users to wait, and you don't want those users to occupy threads running on your machines. A lot of people complain, okay, but how do we communicate back to the user that a given job has been completed? I recommend using WebSockets because this way you don't have to use mechanisms like polling and so on that are very inefficient in the long run to check when the job was completed. You can actually just say it directly to the customer. Point number 6, file uploads. If you plan to have them, do not store the files on worker machines. Make sure to use from the start a centralized document storage system. Having to run a file system cluster between your workers will seriously complicate everything, and if you ask me, avoid it whenever possible.
As most of you probably guessed correctly, the building behind me is a distillery because, yes, I'm on an island that actually produces, grows a lot of sugarcane. And what you can do with sugarcane? Well, you can make sugar, and of course you can make alcohol. The smell inside the building was of course amazing. And what's very interesting here is that the rum they are producing is actually made from the sugarcane juice. I have no idea how it tastes, but I can assure you I bought a sample, which I'm going to try out when I get back to the hotel, because of course when I'm drinking I'm not driving. The city I'm visiting right now, it's called Porto da Cruz, and this part of the island I have never visited before, but I must admit I'm very positively surprised because it's really lovely here. As you can see behind me is this little piece of land, and out there you can see mountains. Well, you can't really see them. This is it. The weather here is changing sometimes very drastically, and as I posted on LinkedIn, sometimes it's just 90 seconds you can see something and then it's over because the clouds are taking over. But I definitely recommend visiting this bit, which is not so touristy, I would say it, but still there's plenty of lovely cafes, small restaurants, and of course the views, they are breathtaking. And as you can see here, if you have an idea about trying out surfing, this is definitely your place.